So hello everyone, and this is yet another interview in our interview session series here at MLOps World Conference. And with us now we have a very known person in the community. Yes, right, Charles Frye, and he's currently an independent AI educator. And I guess most of us know him from definitely know him from the LLM bootcamp, which was really popular recently. So, Charles, how did you end up as an AI and what was your journey?
So I went to grad school out at UC Berkeley, and I was looking around at what I could do. This is like 2014, and it seemed like this whole neural networks thing was really going to take off. And I liked it, being somebody like neuroscience, psychology background. It was like, this is like computer programming, a little math and stats, but it's still related to neuroscience, still related to problems of like thought, perception, cognition. But it seems like it's actually working to bring computer vision, natural language processing to life. So dove into that. Found out during my PhD that I really loved the teaching and educating side. When I finished, I looked around, and turns out there are roles out there in the industry for education with names like developer relations. So I joined Weights and Biases, experiment tracking company to teach people about deep learning using their experiment tracking tool. Worked there a couple years, and then worked on full stack deep learning course that's more MLOpsy, a little bit like train your own models from scratch. And then the LLM bootcamp this year, that was starting from foundation models, turning those into applications, and in all cases, it's just, I really love learning about this stuff. I really love diving deep on it, getting to learn about, talk to the leading researchers and engineers in the field, and then share that back out with everybody else.
So coming a little bit back to the experiment tracking piece of it, so what do you expect of course, we are experiment tracker, so I would be I have to ask it. What do you expect of an experiment tracker, especially in current world of large language models?
So one of the biggest distinctions with experiment tracking for neural networks as opposed to other types of machine learning is that they operate on human relevant data, unstructured, people often call it. So images, natural language, audio. And so because you are operating on that kind of system, you want first-class support for that kind of data. So that means you need a different data architecture as the person providing the experiment tracker. You aren't collecting up a bunch of small little scalars that have some meaning attached to them. That's columnar data. And so that's an important piece. Relatedly, when you're doing your experiments, when you're working with these generative systems that produce unstructured data in addition to consuming it, you very rarely do you actually know what the questions are you're going to have to ask later. You don't know where the bug is going to be, I know that 10% of my lines of code are buggy, I just don't know which 10%. And so you really want to be able to log the least processed version of your data as possible, the rawest version of it, which means a very large volume and a great degree of heterogeneity, and then anything that you might need to resolve a hypothesis, be able to calculate that from the stuff log to the experiment tracking service. So for example, a lot of people will calculate mean squared error and log that with their experiment tracker. And that's a good idea because you probably are going to need that signal, but it's derived from two signals that you should log anyway, the input image and the output image. So being able to have that the flexibility to construct whatever metric it is that just clearly delineates what the problem is with your system and how to fix it. That's when experiment tracking goes from being this nice to have thing that if you spend enough time with it, you can eventually improve your system, to something that is in a hot, fast loop for improving your system.
Right. And not necessarily super experiment tracking related.
Sure.
Let's say you want to analyze the outputs, right? So you're always interested in the outputs, in relation to the input and output, prompt engineering, maybe. Fine tuning and the output. So would you also see the necessity of kind of search the output space in a more complex way, because of course we can do regex, but that's
Yeah.
maybe enough.
Yeah,
You
that's
see it.
it's a great question. I think of this as I call it exploratory model analysis. By analogy to exploratory data analysis, you want to explore the input-output relationship, and so it ends up involving a lot of the same problems that exploratory data analysis involves, which is like you need a flexible system for querying and understanding the data. You need like tools for exploring it. I think natural language, humans are so good at like using natural language. It's our primary interface between each other, like for example right now. And so we're very good at like controlling it and manipulating it. So I think language model powered tools for exploring language model outputs, very powerful. I think things like grabbing 100 rows out of like sample rows out of your log data and passing it through a language model like ChatGPT and just being like, what are some themes, right? It can be a powerful adjunct to like doing the same thing manually. And you can imagine sort of smaller versions of that, like automatic cluster discovery in natural language, or So I think these models that we're building, these generative models that we're building, especially the text controllable ones, are giving us the ability to like use natural language to explore otherwise hard to explore data. Useful adjunct to regex and lexical search.
So I didn't want to spend too much time on experimental tracking because you are also you're very fresh coming out of, I guess, academia, right? To be in a very important field when it comes to actually understanding how the systems work in reality. As you mentioned, like you're almost neuroscientist rather than an actual computer scientist. So what kind of ideas do you bring from this world?
Yeah, that's a great question. So I'd say there's two important branches there, which is one is understanding these systems at a deep level, like understanding the circuits inside of a transformer. That is something where there's just like a ton of skills from neuroscience that transfer fairly directly, algorithms and skills. So Anthropic has been doing a ton of great work on this. OpenAI also does, they've been publishing less of this work recently, I think, but they still do a ton of great work. And they hire neuroscientists, they use neuroscientists, and the skill set is being able to take a like complicated system that you can't really fully measure and observe the way that you would want, that's like in some ways language models are like not really built by humans. We built language model training systems that build language models. In a similar way, brains were not built by humans. Evolution shaped them. And so there's like a similar kind of mindset that's distinct to the like reverse engineering mindset that a computer scientist or a electrical engineer might have for reverse engineering a human design system. And so, seeing a lot of crosstalk there, for example, like, sparse autoencoders were used to crack neural codes in the 90s and are now being used by Anthropic to understand the internals of language models. There's also people are getting excited about AI agents and about developing agentic systems out of these language models, using the language model as this like cognitive processor. And it feels like the agent field is kind of like speed running, reinventing a bunch of ideas from cognitive science around, short-term memory, working memory, the distinction between like fact memory, like semantic memory, and episodic memory, which is like memory of things that have actually happened to the agent, thinking about the role of reward and how reward shapes an overall system. I see both of those places. So at two very different layers, at the fundamental infrastructural layer of understanding the models themselves using techniques from neuroscience, and at almost, like the application layer of understanding what a cognitive system is using ideas from cognitive science and neuroscience.
And back to the agent.
Yeah.
Do you think that so there's a lot of talk about we are now using agents because the large language models are not strong yet, but eventually agents are not necessarily necessary anymore. Do you think that might be the future, or do you have a different opinion?
That's an interesting question. So yeah, I would definitely not dispute that agents are the most demoable and like least usable, like gnarly combination for applications of highly capable generative models. I think pure text completion language models, like let's just keep scaling up this text completion thing with some instruction fine tuning. I think that that's fundamentally a limited paradigm. And I think any of the people who are currently training these models would say the same thing, that they want function calling, that they want retrieval. They want all the things that, once you wrap a while loop around them, become like an agentic architecture. They want all of that as part of the model, but it's moving away from just being a language model at that point. Language models may be just a pre-training step, right? So I think you will always have those components as like kind of discrete functions of the system as a whole, maybe discrete functions of the underlying model, discrete behaviors. In a mixture of expert systems, they might be like distinct experts, for example. But yeah, so I doubt that it would vanish and it would just go back to just looking like the GPT-3 API or just like looking like language completion. The other point I wanted to make is that there's this, when people say, oh, if we have more powerful language models, I think a lot of people are thinking about like pushing out the scaling laws for language model performance to another order of magnitude. And I think that is a good idea and something worth trying, but I think a lot of people who are working on these agent architectures that are doing things like answering email, they look at the capabilities of GPT-4 and they're like, yeah, well, it knows everything about French history and it knows like a bunch of, knows 50 different languages, but I'm writing an email client for people and all I really need is something that knows how to turn like some business emails into a response to a business email or knows how to extract structured data. So I think there's an opportunity to move to more capable as an agentic system, maybe pre-trained or fine-tuned in a way that better supports like agentic behavior or like the specific needs of that, but is not a larger model. It's more capable in a narrow sense, but maybe less capable as a generalist system.
So this might be a little bit technical. Okay, maybe it's not super technical, but when it comes to building agent systems.
Yeah.
So are you framing the entire agent system to perform a task, or are you training separate models separately and then running it? How does it work?
Yeah.
I'm not an expert here, so.
Yeah. Right now, I think people are not training, nobody is really like publicly training these things like end to end, like especially like with a large language model as this like internal cognitive component with a retrieval system. Part of the problem is like there's a lot of non-differentiable components, right? There's a lot of stuff that you can't use the methods of fact propagation that we use to train the like core language model. Like if you have a retrieval system, like you can't backprop through Redis, not yet. And so you probably need something that looks more like reinforcement learning. Reinforcement learning is a lot harder. It's a lot less controlled. The definition of reward is a bit unclear in this case. And if you define some very generic reward, you run into problems of like reward sparsity, reward hacking. So it's pretty hard to train them end to end. And you can get a ton of mileage out of like prompt engineering, out of improving the individual components as a discrete component. And other approaches that don't involve that. Maybe a little bit of fine tuning on a specific component, but not trying to train the whole thing end to end. I think there are researchers like Jan LeCun, for example, who are like big advocates of train the thing end to end, because they've always been big advocates of train the thing end to end since before neural networks were popular. So they still think that's the way to solve it. Maybe it is, but right now I think the open community is like pushing the like modularized approach.
You mentioned also importance of memory, from memory in agent system. What does that mean? Like, how do you explain it?
So for in cognitive science, there's a distinction between semantic memory and episodic memory. Semantic memory is like a memory of a fact, and episodic memory is memory of something that has like happened to you as part of your life. So like for me, Joe Biden as president is an like semantic memory, but for Joe Biden, I am president is an episodic memory. It's about his life, and that for an agent system, what most people are currently doing with retrieval is more like semantic memory. It's like, oh, I attach it to my documentation, and now it knows everything about Neptune experiment tracking and can answer questions about it. Right now, there's some memory stuff that just uses the prompt as memory, right? So just like store previous interactions and use that as like, keep track of that and make that memory. Maybe you summarize the previous conversation, stuff that into the prompt, treat that as memory. That works. It's a little bit closer to, in cognitive science, working memory, like memory of just like, not what you're currently perceiving, but what you've perceived within the last, 10, 30 seconds. And so the piece that only a few systems currently use is more like an episodic memory, where you store information about what the agent has observed, and then you would retrieve from it much the way you would retrieve from the semantic memory, because the semantic episodic distinction is a little fuzzy. So it would look a lot like current RAG patterns, but instead of retrieving over an external system, you retrieve over something internal, like a system controlled entirely by the agent. That's just like...
That's the agent writes some memory into vector store.
Yeah.
And then it uses how long it wants to...
Just the one example of an implementation of this pattern would be the generative agents, the like paper from mostly researchers at Stanford, I think, that was a bunch of like interacting kind of villagers in like a Harvest Moon or like a Stardew Valley kind of video game. They had this where they would look at their like sensory information, what had happened to them recently in a kind of working memory, and they could choose sometimes to write to a store that would later be retrieved from. Like they could reflect on what had happened to them over the past 30 ticks and be like, you know what? I think I actually don't care for basketball after they lose a game, and that gets written back into their into their episodic memory or that episodic memory. It's part of what defines the agent, right? Our experiences define ourselves, and the things written into that episodic memory are distilled information from what has occurred to the agent that ends up defining it as an entity.
It makes sense. Actually, each agent is different.
Ideally.
Running in different environments. So I think we're running out of time a little bit, but I want to ask your final question. So, what is your prediction on large language model generative AI in the next 1 to 2 years?
1 to 2 years, yeah.
What you would like to see? Even though that's not realistic, but maybe you're suffering about.
One, I'd love to see more catch up from open weights available solutions to the proprietary systems. Maybe they'll always be a little bit behind, or for the foreseeable future, a little bit behind in terms of capabilities, but like continuing to eventually implement those things that the proprietary model providers have. Maybe most critically right now, that's multimodal support. I think we've seen just like incredible results reported from Google with Palm E. They're like multimodal model that's like kind of specialized for robotic systems. We've seen with GPT-4V like that you can get pretty impressive, like unlock new use cases by like directly connecting the model to an alternative sensory modality and not just text. But right now there aren't really like tooled around with some of the open models, but they're like the quality, it hasn't crossed that threshold to like being hackable to utility. I think, for many cases, outside of obviously image generation, which there are great open models for. Yeah, so I want to see, like, expect to see and I want to see a lot of improvement on that. And I think that will drive, looking further to the future, 4 years to 7 years out, like more capable robotic systems that combine this multimodal sensory input, ability to do tool use on a robotic body, and like an agentic like architecture that accumulates information over time and can take actions in an evolving world.
Yeah, this is an amazing picture of the future that you're painting. So maybe you want to leave our listeners with some thoughts. For closing up.
Yeah, I guess yeah, I would say there are a lot of people who are entering this field from software. And I think there's a ton of great instincts that you're going to bring, and there's opportunities to build really like awesome stuff right now with that skill set. Like, you don't have to learn that much ML actually to make use of these things. I think eventually people will start to bring in ideas from cognitive science and ML to the development of these systems. So it's worth paying attention to those things, but it's not worth saying, oh, well, you know, I guess I got to sit down and do a master's in cognitive science or ML before I can even touch these things. So go out and hack on it, give it a shot, run your own homebrew cognition club if you want, and try it out. And if you're an ML and you are used to training models from scratch, rather than like, you know, prompting your way to an application, I encourage you to move away from just experimenting and model building and towards application development. You know, maybe learn a little bit of JavaScript, a little bit of React, so that you can actually, you know, stand up a tiny application to share with your friends and family. You know, like get out there and yourself hack, but, you know, moving in the direction from ML to like software and applications.